Hello guys. So now this is the second video of the preparation of the exam, and we have solved some basic questions. So now this is the question which has a few more numbers around the trigonometric ratio. So for these kind of questions, firstly you must remove the other numbers around the trigonometric ratio, around the sine of angle part. This part should be single at the end. Sine of x minus pi over 5 should be equal to a number. We must try to guess something like that. To make it happen, firstly you move minus plus root 3 other side as minus root 3. It will be equal to 2 times sine of this part is equal to minus root 3. Then you will have sine of this part. It will be written inside the parentheses minus root 3 over 2, which is, let's write it in here, minus root 3 over 2. So now this is the question like we solved in the previous video. Heidi, after this you try by yourself. Let's pause the video and try to solve it by yourself. So guys, I have paused saving the video. They tried, the students in here, they tried to solve it by themselves. So now I will show the true solution and they will check their answers. If you try, you can check yours also or just watch them. So then, firstly we will try to find which two angles can we put inside the unit circle. From the unit circle, which two angles can we put in here? Since the result needs to be negative, these two angles should be in third and fourth quadrants. So now we will place the angle around the x-axis. The angle, if we have a positive result, the angle between 0 and 90 degree if we have a positive result. So like 30, 45 and 60 or 60. Sine of which angle makes root 3 over sine of which angle makes root 3 over 2? Let's show. Sine of 60 degree. So the 60 degree must be over that. I waited a bit because right now on this board I show you that we close the minus with my hand. But the people who watches this video, they will not be able to see my hand in here or the shadow of my hand. They will not be able to see. They will all see just this place, just only the pen moving around. So probably when I mentioned that, what if we have a positive result? What should be the angle from 0 to 90 degree? What should be the angle? So the angle must be 60 degree. Then we place that 60 degree around the x-axis. So now these are the two angles. How can we show those angles? So the first one from 0 until here, 180 plus 60 makes 240. The second angle from here until there, we can show it simply 360 minus 60 makes 300 degree. Or in the class when we make these kind of questions, I have given you something like this. 300 is a big number. We may also use it like negative 60 degree. From 0, if you go down in negative direction, you may also show minus 60 degree. They both mean the same thing. 300 and minus 60 degree, they both mean the same thing. In the class I have told like that, but just use as you learned today. Just use as you learned today. So now let's continue to make the solve the example. So pi over 5, let's find it somewhere. Pi over 5 is 180 over 5. Look at that. 180 is 18 times 10. 18 times 10. 10 over 5. 10 over 5 makes 2. 2 times 18, 36. So when I write the solutions, I will directly use 36 in here. Now the first type of solutions, x1 minus pi over 5, which is 36, should be equal to first number 240 and plus 2k pi. Minus 36 will come here as plus 36. So x1 is equal to 276 degree plus 2k pi. Is k element of integer numbers. So now x2. For x2, we will write all the things like in parentheses, x2 minus 36 degree, and the result should be 300 and plus 2k pi. So to get single x2, we must move minus 36 other side, like plus 36, so it's going to be 336 plus 2k pi, and k is element of integer number. Normally, I would give you another question like this, I have told before. It will take so much time. Do you want me to move to the second type of questions which I may teach you today, right now in today? We forgot the tangent and cotangent. Okay, let's solve one simple question. Let's solve one simple question about tangent and cotangent. For example, let's solve like the first question. Heidi, try to solve the first question by yourself. We have done it in the class before. Pause the video and try to solve. So guys, now we pause the video. They try to solve. Now I'm gonna solve the question for all of you. The people who are in here and the people who watch the video. So now, firstly, tangent gives us positive results in which quadrants? In which quadrants? In the first and third quadrant. The result of tangent is positive. So now we already had a positive result in here. In basic part, which is from 0 to 90 degree, tangent of which angle makes root 3? Tangent of 60 degrees. So I'm going to put this 60 degree for these two angles around the x-axis, not to the y, not to the y, around the x-axis, 60 degree, around the x-axis, 60 degree, not to the y, to the x, angle and to the x. So that, here we have the two angles. The first one is from 0 to plus 60, the second one from 0, 180, plus 60 more, 240 degree. There is only one thing which you need to remember. For sine and cosine, there are x1 and x2. For both of them, we add plus 2k pi. For tangent and cotangent, there is only just single x. For this single x, we only use plus k pi. Because in tangent and cotangent, we have something like it goes from one angle to other one, like plus 180, plus 180, plus 180, plus 180. It goes like that. So, the results you wrote in here, you wrote two results. Actually, they give us all positive, all possible answers, but we can show it shortly. It is also true what you wrote in your notebooks. It is also true, but we can show it shortly by using these notations. So now, from the two angles, choose the smaller one, 60. 3x is equal to 60 plus k pi. We need a single x. What do we do? Division. Divide by 3. Divide by 3, divide by 3, and divide by 3. So right now we have the single x. We can write that k needs to be an integer number. So now your next question. Cotangent of x over 2 is equal to negative. Let's put negative in here. Negative 1. Heidi. Let's try this one. So now, everybody pause the video and try to solve it by yourself. Okay guys, let's finish this part. We have paused the video. Now we continue to record it. I prepared the same example in an empty place. So now, in the angle part, which angles can we have over there from the unit circle? Cotangent is negative in second and fourth quadrants. If we would have positive 1 over there, the result between 0 and 90 degree, it is 45 degree. So now we will place this 45 degree in second and fourth quadrant around the x-axis. So next to x-axis, the 45 degree, next to x-axis, hard to pronounce it. So now the first angle from 0 until here, 180 minus 45, 135. The second whole angle, 360 minus 45, 315 degree. So for this kind of, for tangent, cotangent, we have one answer. You may use any one of these two numbers, doesn't matter. You may use first or second, doesn't matter. But the smaller is easier to use, that's why we use smaller one. Plus k pi we add. With tangent and cotangent, plus k pi, sine and cosine, 2k pi. And we have two answers. So then to remove over 2, we make multiply by 2. 135, 270 plus 2k pi. So now, the other type of questions you may see in exam, these are still same type of questions. So, these kind of equations, to solve this kind of equations, you must factorize, making it right now will take too much time and it will be a bit confusing for you. But I can show you in the beginning a bit faster. We have done this in the class. So in here you make common factor parentheses. I also asked a question like this in quiz, like the first one in quiz with cotangent. Sin x, if you take sin x parentheses from first, sin x comes. From second, just plus 1 is equal to 0. Then one of them must be 0. Here, open form of sin x, 2 sin x cosine x. Then you take sin x parentheses. So from first, there will be 2 cos x plus from second, just 1. Then remember that two kind of answers. Any one of them can be equal to 0. The third one is factoring. Here you write 1 times 2, here you write 1 times 1, and you try to arrange minus 3 for the cross product and add. You try to arrange minus 3. So to make it minus 3, both of them should be minus 1 over there. So in here you must move this one to this side. 2 cosine squared x is equal to 3 sin x. After that, 4. 2 cos squared x is minus 3 sin x equals 0. So in this kind of equations, if you have different powers and different letters, you try to make them same letters. Instead of cosine squared x, we can use 1 minus sine squared x. I think double of sine squared if I remember. No, just 1 minus squared x. Just 1 minus squared x. We have done it in the class, but it will take too much time right now. So I want to try this kind of equations, which is cosine of something is equal to cosine of something. Sine of something is equal to sine of something. Or here, the other kind of thing, it can be tangent equal tangent, cotangent equal cotangent. So from this part, the confusing one, what if we have different ratios in both places? So that's the different one. So firstly, let's remember these things. If you have cos equal to cos, you just take the second number in here. Firstly, you write it with positive a. Secondly, you write it with negative. If you have sin equal to sin, firstly, you write it with positive as it is over there. Secondly, you make it 180 minus whatever you have in there. 180 minus whatever you have in there. Then, if you have tangent equal tangent or cotangent equal cotangent, they both has the same idea. You just write that whatever you have in the second place plus k pi. So, firstly, let's make very simple questions. Sine equals sine. Let's say sine of 3x is equal to sine of something divisible by 3. 90 is simple. 36. This is your question. Now pause the video and you can move it back. Try to remember the rules from here.
Now, let me pause the video.
Now, so guys, these are the rules which I have showed you before. Now, I hope that you try it by yourself. So, let me try to explain the ideas to you. So now, look at that. If we have sine of an angle is equal to sine of 36, which is the result for sine 36 is in here. So you can get the same result if you draw this angle in here with 36. If you draw the same angle in here with 36, which is 180 minus 36 will have the same result on y-axis. So let's do that one. The first kind of results, whatever you have in angle part, you write it in here. So you write the number directly in here, plus 2k pi. Then the second kind of results, whatever you have in angle part, you write it over there, equals 180 minus the angle you have, whatever angle. Sometimes there will be something larger than 90 degree. There can be like 120. There can be something like 170. Doesn't matter. 180 minus that angle you have in here and plus 2k pi. So now let's solve the first equation. We divide everything by 3. There will be x1, 12 and 2k pi over 3. And we must add that k element of integers. So now in here I solved that. All of you first did the subtraction then division. I solved that. But remember, or my idea, we already divided 36 by 3. So dividing firstly will be easier. x2, 60, 12, 2k pi over 3. Then subtract. This is 50, 48 plus 2k pi over 3. I hope that you have the same answer on your notebook. Then let me ask you a simple question about the cosine. Now this was about sine. We can finally make something with cosine. Let's say we have cosine of x over 5 is equal to cosine of, let's make a big angle, 140. Pause the video and try to solve this question by yourself. So guys, let's continue. I have prepared it in empty place. So right now, the rule with cosine, whatever you have in the first place, it will be equal to positive 140 plus 2k pi and negative 140 plus 2k pi. Now the first kind of solution, positive 140 plus 2k pi. So to get single x1, multiply by 5. x1 is equal to 5 times 0 is 0. 5 times 4 is 20. We have 2. 5 times 1 is 5 plus 2 makes 700. And 5 times 2 makes 10k pi. So for the second kind of answers, x2 over 5 is equal to minus 140 and plus 2k pi. So we must multiply it by 5. So x2 minus 700 and plus 10k pi when you multiply. So guys, the real type of questions is, right now I hope that even if I ask you with tangent, you can find. Tangent and cotangent, they have the same idea. For example, let me do it very fast example. Let's say we have tangent of 5x is equal to tangent of 40. What do? You directly write that 5x is equal to 40 plus k pi. And right now, you must do divide by 5. So x is equal to 40 divided by 5 is 8 plus k pi over 5. With tangent and cotangent, just k pi, not 2k. Sine and cosine, 2k pi. So now, let me ask you a real type of question, which is the one which a teacher likes, which a teacher likes. For example, let's add a page. Okay. What if you have something like tangent of 3x is equal to cotangent of 50. 50 is not good. Let's make it 52 and 51. It will be divisible by 3. 51 degree. So now, solving these kind of questions. To solve this kind of questions, you need to remember something from 10th grade. And 3 minus 8. So, guys, remember this. Reference angles. For the reference angles, we can use 0, 90, 180, 270, and 360 degree. Okay? If we use 0, 180, 360, if we use the ones from the x-axis, we don't change the name. If we use 90 or 270, we change the name. So right now, sine 90 used. It should be cosine of A. Remove the 90. Cosine with 90 degree. So change the name. It is same with sine A. Tangent 90 degree plus or minus. Doesn't matter what you write in here. So, but the one we need in here, the negative one. 90 minus A. Tangent 90. So because of 90, tangent, change it to cotangent A. Cotangent 90 minus A will be opposite tangent A. So guys, in 10th grade we also have done this. After you change the name, you must be careful about the sign. Will it be plus or minus for the real question part? Right now 90 minus A, which is somewhere in the first quadrant, the result should be positive. This one should be positive, positive, positive. But normally, it can be negative also. For example, if I have cotangent 90 plus A, the result of it, tangent A, you change the name because of the 90, then 90 plus A, it should be something in second place. So that's why it has to be negative of tangent A. So now, let's come in here. Look at that. In this question, the problem is the trigonometric ratios are different. So then, we must change one of them. So make them same. Instead of cotangent 50, I need tangent 51. Or tangent of something. If I write it cotangent, how? So what would I do? So cotangent 51 same with tangent 90 minus 51. It is same with, look at that. Cotangent, I need which one? I need something with tangent. So cotangent 51, I need something with tangent. Tangent 90 minus 51. Tangent minus. So you can simply memorize it in your mind like this. Use one of the parts, change one of the parts. Whatever you have in here, use the different ratio, use the different trigonometric ratio, write it like 90 minus whatever you have in here. 90 minus whatever you have in here. So tangent of 3x. So right now we have tangent and tangent. So if we make a subtraction, tangent 3x is equal to tangent of 90 minus 51? 40, 39. 39 I think. So 3x is equal to 39 plus k pi. No, remember, divide by 3. 13 and k pi over 3. So use different name and subtract the main one. Subtract, how do we subtract from 90 degree. So now, this is the question for you. What if you have sine of x over 2 is equal to cosine of 10 degree? Try this one. Pause the video and try to solve this one by yourself, everybody. Yes, guys, now I prepared the question in an empty place. So, we must have the same trigonometric ratio so we can find an answer. That's why we write sine of x over 2 and we try to change this one. Instead of cosine, I need sine. That's why I can change it like sine of 90 minus 10. Which means because of sine, if you go back, because of 90 degrees, sine will be cosine and 10 goes there without the reference angle part. So then we can directly write that. Remember that with sine we have two kinds of an answer. The first x1 over 2 is equal to, there will be 80 in here. Directly 80 plus 2k pi. Do you remember the second one? Let me try. Okay, now I remember. The second one is 180 minus the angle you have in here and plus 2k pi. So now to remove over 2 we must make times 2 x1 160 plus 4k pi and k is integer. In here to remove over 2 times 2 x1. So this part will be 100, 2 times 100, 200 plus 2 times 2, 4, k, pi, and k is element of integer numbers. So, this is not only for you, this is also for the people who are watching this video. In the exam, I have asked you, I have given something like this to you. Sine of an angle is equal to cosine of 100 or 200, I wrote it there. So, I just want to show the people who watches the video. Cosine 100. So everybody was confused when we have a bigger, a larger number. So in algebraic method, if you have cosine of a, you can show it as sine of 90 minus a. So in algebraic form. So I used the algebraic idea with the number, which is I show with sine of 90 minus 100. So right now I have sine of minus 10 degree. Look at that. If you check this on unit circle, the first angle 190, after 90 we have 10 degree more, 90 plus 10. So when we have the hypotenuse one, opposite side of 10 will be cosine of 100. Let's say minus a. Opposite side of 10 is, let's say, a, and cosine of 100 is minus a. So now the result we need to find sine of minus 10. If you show minus 10 degree, it will be in here, minus 10 degree. So when you have the hypotenuse one, opposite side of 10, we have mentioned that it is going to be a. So sine is the y number, so y number in here is going to be minus a. So both of them will have the result minus a. So there is no problem about using this algebraic idea, directly in the question. There is no problem about that. So now let's do what? Let me think a bit. So now guys, we will solve a few more questions from the last part, which is I am going to teach this part on Monday, the day before the exam. So you can study, you can learn by watching this video, I hope. So firstly, we will talk about calculating area in a parallelogram. So you try to calculate the distance between the two parallels. You can calculate it anywhere over there. When you find this distance like x times the base 12 gives us area. Or you may try to calculate the distance between other two parallels. You may try to calculate the distance between other two, or you may calculate it outside of the polygon. So when you calculate this distance, right now this parallel is the base, so 6 times 8 gives us the area. Actually this answer is 6 times 8, 48, 12 times 4 must be there, 12 times 4 must be there. So we will solve 2 more questions about calculating the area, but the thing which I care a lot, which is sharing the area in a parallelogram. We did a review about array of triangles. That part, array of triangles, will not be in the exam. So I made that part so you can understand how to share the areas in a parallelogram. So the main idea is, look at that. You can, if you draw this diagonal, it cuts the area into 2 equal parts. Do you see it? Or if you draw the other diagonal, it cuts the area into 2 equal parts. So, let me show you something else. If you draw lines connecting the corners, starts from one corner and in the other. So the triangles which has the base on bottom. But the idea is they should complete all the bottom part, and the triangles, they have the base on top. The triangles, they have the base on top. So some of these 2 areas, half of complete. Some of these 3 areas, half of complete. I hope that you can get the idea. Or you may make it like this. You draw the line from this, between these 2 parallels. So this triangle, which has the base of it, in the left side, it has the half area. Some of the other 2 triangles, which has the complete bases in the right side, they have the half area. This idea, this logic is very important. So now, the most mixed questions which you may see about that, or when we use diagonals and ratio of diagonals, it gets a bit more mixed, of course, but the basics. For example, firstly, in here I gave you the whole area and I asked you to find the painted part. So right now, to compare areas, we always need triangles. In each place you make triangles. In here, connect the vertices, connect the corners, connect the corners. So right now, every place we have, here we have a triangle, a triangle, a triangle, a triangle, triangle, and a triangle. So guys, the ones which has the base, bottom, these 3 triangles has half of the area. The ones which has the base, let's show it with blue, top, on top, the 3 triangles in here, some of the areas of them is half of the area. I hope that you get the idea. So then, the complete area is 108, so half area is 54. 54, half area. So now, by looking bottom, by looking the red ones, 54 divided by 3. You share it into 3 parts. Each part will be, in 5 we have 1 times, in 24, 8 times. Each part will have the area 18. 18 in here, 18 in here, 18 in here. By looking top, how many parts do we have in here? 1, 2, 3, 4, 5, and 6 parts. 54 divided by 6. I share the half area into 6 parts. 6 times 9. So each part has the area 9. So here we have 2 parts, this area 2 times 9. Here we have 1, 2, 3 parts, 3 times 9. Here we have just a single part, 9. So the area which I have been looking for, the painted, is equal to 18 plus 3 times 9 is 27. Which makes 7, 7, 16, 15, 45 is 35. 45. Huh? So this is the first type of question, which is if I give you whole area. So now this is the second type of question. Like in triangles, if I give you the painted area, so again we need half area. In here, half area. So then, right now we don't know how to shade 132. How much should be there, how much should be there. So for this kind of cases, if I know the complete, I can figure out how much is the half. But right now, I don't know how to share 132. For this kind of cases, we use the method of naming. So, when I name half area, that half area, look at that, in the previous question, I divided half area, firstly by 3, secondly by 6. So in here, if I look for the bottom part, how many parts, bottom side, how many parts do we have in there? 1, 2, 3, 4, 5, 6. Here we have 6 parts. For the top, how many parts do we have? 4 parts. 1, 2, 3, and 4. So the half area should be divisible by 6 and by 4. What is the smallest number for that? Divisible by 6 and 4. The smallest number you can divide by 6 and by 4. For example, we can divide 20 by 4, not with 6, but not with 6. What can be the number we can divide? We can divide that number by 4 and by 6. What is that number? 24. Can you find 24 divided by 4? We can do. Divided by 6, we can do. Can you find something smaller than 24? So look at that. Even if you don't know how to get to 12, you can do it like 4. Find multiples of 4. 8, 12, 16, 20, 24. Find multiples of 6. 6, 12, 18, 24. So when you find the smallest common multiple, that's the half area, 12a. Let's say you couldn't find 12, you work with 24. Let me try, is it working as well or not? 24a. Let's say half area is 24a. We weren't able to find 12. Doesn't matter. Let's check that. So if half area is 24a, how much is the total area, complete area? Double of 24, 8, 4. 48a is the area of ABCD, all area. Am I right? Understand? So I mentioned that half area is 24. Now I am going to divide 24a into 6 parts. How much is each part? 24 divided by 6. How much? 4a. For one part I have 4a. For one part I have 4a. For 1, 2, 3, 4 parts I have 4 times 4, 16a. 4 times 4, 16a. So now the half area I will divide it for the top side into 4 parts. 24 divided by 4, 6. So each part will have the 6a, one part, 6a, 2 parts, 2 times 6, 12a. So now painted is given. Painted is equal to how much? 132. So painted area 16 plus 6 makes 22. Am I right? 22a is equal to 132. So a is equal to 132 over 22. Can we find it? Can we find such that number? I think it will be with comma. Let's try. In 13 we don't have in 132. How much can be there? 4 times 2, 8. 5 times 2, 10. Let's check 5. 5 times 2, 10. We have 1. 5 times 2, 10. It will be 11. Let's subtract 2. 2. Is it 6? Yes. Oh, let's check 6. Let's check that. Can we get? So let's check the number 6. Let's check the number 6. 6 times 2, 12. 6 times 2, 12. We have one more, 13. So 6 is the number. A is equal to 6. So right now we are looking for find area of ABCD. The total area, 48 times 6. 6 times 8, 48. We have 4. 6 times 4, 24 plus 4, 288 is the final answer. Thank you for watching and listening me, guys. Sorry, my last verse sounded really bad. I'm not so good in English. Sorry once again. Let's stop this video.